Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Dear colleagues and PGs, from today we shall start discussing hepatitis E virus. And this is relevant as well because the current rains and floods have enormously increased the risk of hepatitis E and hepatitis A in the country. We shall discuss the virology, diagnosis, clinical course, and treatment options of hepatitis E virus in the coming 3 or 4 videos. Today, we shall discuss the virology of hepatitis E virus, its genotypes, distribution, and their clinical relevance. So, starting the update on hepatitis E virus in the part 1, we all know that hepatitis E virus accounts for more than 50% of acute viral hepatitis infections in young adults, with a case fatality of 1 to 2% in regular patients and up to 20% in pregnant women. If we look at the epidemiology of hepatitis E virus, countries in the world have been divided into 3 main groups. Those countries where the hepatitis E virus is highly endemic and they have more than 25% hepatitis E virus cases. These are shown here in the dark green. And Pakistan is in the dark green component. So the prevalence of hepatitis E virus is really very high here in Pakistan. Then the light green, where the prevalence is less than 25%, and yellow, where the prevalence is not clearly known or they are not endemic. According to WHO, every year, 20 million cases, they develop hepatitis E, 20 million cases. And out of these 20 million cases, 3.3 million, they are symptomatic. And out of these, 70,000 patients, they die each year. So every year, 20 million cases, they develop hepatitis E. And out of these 3.3 million, they are symptomatic. And out of these 70,000, they die. So these are very alarming figures. When we see the history, it was Khuroo et al. Who first identified hepatitis E as an unknown non-A, non-B virus during an outbreak of jaundice in the winter of 1978-79 in Kashmir. Then the Russian army doctor provided the first evidence of fecal-oral transmission of this virus by the ingestion of diseased soldier stool. This new virus was detected in his stool by electron microscopy. The viral genome was cloned and named hepatitis E virus in 1980. When we see the structure of the hepatitis E virus, it's a single-stranded positive sense RNA virus. So hepatitis E is a single-stranded positive sense RNA virus. And it exists, the virion of the hepatitis E, they exist as non-enveloped spherical particles in feces, like this, but exist as quasi-enveloped or enveloped particles in the circulating blood. So when you see them in the circulating blood, they are either quasi-enveloped or enveloped viruses, enveloped particles, and when you see them, examine them under the microscope in the stool, they are naked hepatitis E virus without envelope. So this is important. Genome of the hepatitis E virus is a single-stranded positive sense RNA molecule and 7.2 kb in size. The genomic RNA is a polyadenylated and contains 3 open reading frames. The open reading frame 1 encodes the non-structured proteins. The open reading frame 2 encodes the capsid protein, and open reading frame 3 encodes a small multifunctional protein. This is the open reading frame 1, the blue one, and it encodes for the non-structured proteins. This is the red one is the open reading frame 2, which encodes for the capsid, and open reading frame 3 encodes for the regulatory proteins. So this is the genome of the hepatitis E virus, and this is important when we think about the vaccines against these viruses. Hepatitis E virus is classified in the family of Hepviridae. According to the 10th International Committee on Taxonomy of Viruses report, it belongs to the Hepviridae, and this family has got 2 genera, the orthohep virus and the pesky hep virus. So these are the 2 genera, the orthohep and the pesky hep virus. The orthohep virus has got 4 species, the A, B, C, and D, while the other has got only 1 species. So Hepviridae family, and the genera is orthohep virus, and it contains 4 species, this genera, and the A species, it is the typical hepatitis E virus, which has got 8 genotypes, genotype 1, genotype 2, genotype 3, genotype 4, genotype 5, genotype 6, genotype 7, genotype 8. I have colored the genotype 1 and 2 as dark brown and 3 and 4 as red ones, and it has got its own significance, which I will discuss later on. The genotype 1 and 2, it's associated with clinical hepatitis in human, while genotype 3 and 4, the clinical hepatitis in human, and which becomes chronic. So to summarize, the hepatitis E virus is a member of the Hepviridae family, and the genera is orthohep virus, and this orthohep virus has got 4 species, A, B, C, D, and the A has got 8 genotypes of the hepatitis E virus, where the genotype 1 and 2 and 3 and 4, they are clinically relevant. This diagram shows the phylogenetic relationship of hep viruses identified in various hosts. The genotype 1 and genotype 2, they are restricted to humans and to endemic regions such as Asia, Africa, and Mexico. So 1 and 2, they are restricted to humans. Only humans are affected by these 2. The genotype 3 is present worldwide in various hosts such as swine, wild boar, deer, mongoose, and Japanese macaques. So it has got the host is animals as well as the human as well. While genotype 4 is found mainly in China as well as Southeast Asia, and in fact swine, wild boar, and sheep, in addition to the human being. And the other genotypes that are present in the other different animals, and no need to go into the detail of that. But point is, in genotype 1 and 2, they are restricted to humans, and genotype 3 and 4, in addition to the humans, they also infect the animals. When we compare these genotypes, the area where they're more prevalent and the source of infections. So the genotype 1, it's prevalent in the tropical developing countries of Asia and Africa, and the source of infection is contaminated drinking water, and no zoonotic relevance, no chronic infections described with genotype 1. The fulminant course in pregnant women with a mortality of up to 20%, in the last trimester has been reported with genotype 1. It is associated with pancreatitis, but not with neurological symptoms assumed. So this is important, the genotype 1 association, source of infection, and the area. Regarding the genotype 2, it is prevalent in the tropical countries of Africa, or Mexico, and Central America. Again, the source of infection is contaminated drinking water. And again, there is no zoonotic relevance. They are confined to the human beings, and no chronic infections described with genotype 2 as with genotype 1. The genotype 3, they are more prevalent in industrialized nations, worldwide distribution, and they are in the Europe, North and South America, Australia, and large parts of Asia. The source of infection is foodborne zoonosis, mainly contact or consumption of the inadequately cooked pork, shellfish, deer, the strawberries, vegetables, spinach, and the blood transfusions. So the blood transfusion is also a source of genotype 3, hepatitis E virus. The chronic HEV infection has been described in several cohorts of immunosuppressed patients, frequently observed neurological symptoms in these patients. And also there's no association with male infertility. So the genotype 3, it's mostly found in industrialized nations. It's foodborne, and it has been associated with the chronic hepatitis E virus infection. The genotype 4, mainly it's found in Asia. Recently, single cases in Europe have been described as well. Again, just like genotype 3, it's foodborne zoonosis, mainly contact the consumption of the inadequately cooked pork and shellfish. Again, just like genotype 3, it has been associated with chronic HEV infections and with immunosuppressed individuals. The genotype 5 has been found in Japan, and the source of infection is wild boar, and relevance for human is still unclear. Similarly, genotype 6, again in Japan, wild boar is the source of infection, and relevance for humans is still unclear. Genotype 7 and genotype 8, they are in the Middle East, and they are in the camels, and the chronic infection in a liver transplant recipient who regularly consumed camel meat and milk was reported with genotype 7, while for genotype 8, relevance in human beings is still not clear. Then there are other types of genotypes of hepatitis E. One is the rate hepatitis E, which has been found in Hong Kong, and the source of infection is RAS. Genetically, it is distinct from the classical hepatitis E virus genotypes and does not classify regularly. Two known cases of human infection, one of them chronic in a transplant recipient, has been reported with rate hepatitis E. Similarly, there is avian hepatitis E, which is found worldwide, and the source of infection is birds, but generally distinct from the classical hepatitis E virus genotypes, and no human cases have been reported as compared to the rate hepatitis E virus, where one case has been reported. This is the overview of the genotypes of hepatitis E virus in the world. So by this, we come to the end of this first part of the hepatitis E virus. In the next part of the video, we shall discuss the genotype 1, 2, 3, and 4 in detail, and the diagnosis of hepatitis E virus in the patients. Till then, Khuda Hafiz, take care of yourselves.